5, 4, 3, 2, 1. General aviation desperately needed a reboot. The market demanded epic new aircraft that looked like flying supercars, performed like thoroughbreds, and were affordable to own and operate. HX50 is the aerial grand tourer. It carries 5 people in their luggage, cruises at 140 knots for 3 hours, and has looks that can kill you stone dead from a mile away. It'll take you places, elevating you to a new and exciting world you never knew was there. To deliver this vision, we needed a new, affordable turbine engine. Powerful, reliable, sophisticated and smooth. Quite literally, the heart of the matter in every way. That heart is now beating, and this is the story of how Hill Helicopters built the first all-British designed, manufactured and developed helicopter turbine engine in the UK since the 1960s. The General Aviation 2.0 Renaissance is here, and all-British whole aircraft manufacturing is back. Let's not kid ourselves, this is an exceptionally difficult thing to do, and there are a number of reasons why this hasn't been done before. The primary blocker to all of this is the simple fact that there is no market for a new GA engine. Even if we go back to the heyday of general aviation in the 60s and 70s, when GA was bigger business than supercars, even then an engine manufacturer couldn't sell a new engine to an end user. Instead, they had to wait for their engines to be adopted by an airframer, wait for the airframer to develop the engine into their aircraft, and then test it, approve it, eventually sell some of them, and then start to place orders on the engine manufacturer. And even back then, that could take 5 to 10 years. For a new engine manufacturer, that simply isn't viable. And since then, the situation's got even worse. We've had a 40-year innovation drought where there's been virtually no new airframe programs at all. It's simply not possible to survive making engines alone for the GA market. What we're left with is legacy manufacturers supporting large fielded fleets with spares with little or no appetite in developing new engines for the GA market. And who could blame them? The GA market has been locked in a 5-decade spiral of decline. In 1978, the industry delivered 18,711 light 4-seat aircraft. By last year, this had dropped to just 1,585 deliveries. On top of the commercial challenges, aerospace has quite rightly always been a highly regulated industry. Over the last 4 decades, these regulations have continued to put greater and greater demands on manufacturers of new and advanced engines. Then there's the technical reality that designing lightweight, high reliability engines for the harsh aerospace duty cycle is itself incredibly difficult. The other major factor that completes the deadlock is the fact that without buoyant general aviation manufacturing, there is no demand for low-cost aerospace componentry. As such, the aerospace supply chain has gravitated towards higher value aircraft at higher price points, and it's now no longer possible to use the aerospace supply chain to produce GA aircraft at a price point that the market can afford. If you attempt to buy components that you would ordinarily outsource, you'll find that your bill of materials is greater than your desired final sale price. The industry has been stuck in this deadlock for decades, and something had to change. Our approach is radically different, and it needed to be, to break the deadlock and succeed. First, we created the no-compromise, iconic new aircraft that people had been longing for. Then we sold it in volume, creating the market to justify an all-new, affordable turbine for GA. It worked. Even before the engine ran, we'd sold 1,457 aircraft in 62 countries, giving us close to $1 billion order book, the most successful pre-sales aircraft program in general aviation history. Now we had the product, the market, and the financial leverage to break the GA deadlock. We built a global team of brilliant engineers, fusing decades of experience developing well-known big brand turbines with raw intellect, drive, energy and determination.
I'm Steve Hill. I've been an engineer since leaving college in 1977. I spent the first half of my career at Rolls-Royce, then moved into consultancy. My main role in the Hill team has been in the design of the turbo machinery and also working on the combustion and the air system.
We avoided complexity and novel technology and built the simplest turbine engine that we could to meet the performance goals. We shunned technical and performance ideals and instead based GT50 on field-proven approaches widely used across the industry for decades, each with accepted methods for design, manufacture, testing and approval. We set out to develop a simple, reliable and importantly deliverable engine. And we were right. However, the single biggest factor in developing the world's first affordable turbine engine for general aviation is our massively vertically integrated manufacturing strategy. An aircraft manufacturer must manufacture, and by that I mean everything, and we do. Having full stack control of our manufacturing processes means that we have complete control over the cost, the quality, the volume and the schedule, and nobody can ever hold us to ransom. Developing these products and this level of capability has been a long road. We started with a small team and minimal costs and incrementally built from there. The idea for GT50 was born in a tiny office not much bigger than a doctor's waiting room. As we started developing manufacturing capability, we built pilot precision machining facilities using the latest computer-controlled manufacturing technology and validated all of our manufacturing approaches. As the design neared completion, we built an entire production center capable of manufacturing every single part of both the aircraft and engine, a truly unique global facility. We built an in-house foundry to cast turbine blades, vanes and structures. We built an in-house precision machining facility to produce bearings, gears, fuel nozzles, discs, shafts and complex couplings. We built in-house precision fabrication capability to press, roll, form and weld superalloy fabrications. We built an in-house precision metrology facility to uphold the tightest tolerances and production controls. We built a temperature-controlled assembly facility. We built subcomponent and whole engine test facilities. Hill has not only developed the first affordable turbine engine to be produced at scale for general aviation, but we've also built and already operate the manufacturing facility that can build every single component of that engine. That's why Hill is different. Not only have we developed the first affordable GA turbine, but we're also ready to scale. I think we had 4 months to go and we were still desperately trying to get the last of the components out of the design office through the release program and into Mark's hands so the manufacturing guys could get going. The problem is, as you come out of the 3D world and go into detailed design, you find all of the little details that you'd missed, be it seal clearances, be it tolerances, be it oversights on manufacturing order, and sorting that stuff out just takes ages. You could really sense the apprehension in the designers as they were having to hand over their finished designs and their finished drawings to the production team to go away and build these parts so that we could test them. I think for a lot of them it felt very much like they were handing in their homework and it was about to be marked, and there was a small degree of reticence to know when to stop, when's enough is enough, and when to let it go. And in our experience subsequently, the sooner you do that, the sooner you build it and the sooner you test it, the better, because that's when the real learning starts. And of course, getting the parts out of design and released to production is really just the start of the fight that Mark then had to deal with in coordinating the enormous logistical task in manufacturing all of the parts, all of the jigs, all of the fixtures, developing all of the detailed processes for making each of these 438 components for the very first time.
I'd say I've been quite relentless, always demanding, but there's a fine line between pushing people and driving them and working them into the grind, so you've got to manage that and balance that. The guys have been working 7 days a week for 4 months.
All of the machines were working 24 hours a day. We'd got guys coming in of an evening to swap programs over and reload machines to keep the production centre producing the parts as fast as we possibly can. It was a long and demanding process on everybody involved.
Working at Hill's very demanding. We put a lot of long hours in to get this engine up and running. Working alongside the engineer, I think that helps push you on, helps motivate you as well.
Working at Hill is demanding, but I think everyone in the team's motivated. We're all good guys, and seeing the work level of other people put in pushes you to do the same really. And we've also got good managers, and everyone's got a good attitude and everyone wants the same thing.
That level of work rate, that level of sustained work rate, takes a huge toll on everybody, and it's not just the guys that are here doing the work, but it's their families, their wives, their kids that are missing out because they're just not there. We owe all of them a deep debt of gratitude, because without their support, without that superhuman level of effort and sustained commitment, this would never have got done. But it takes more than just effort. Effort alone isn't going to get this done. The huge task of coordinating all of the plating processes, all of the heat treatment processes, all of the inspection processes, the X-rays, the NDT, all of the plethora of things that have to be done in sequence to make all of these components was being coordinated by Mark to make sure that we never ever bottlenecked any of the production processes that were going on here. Just walk us through some of the examples of some of the things that we've had to battle to get these things done.
That's been my biggest headache, if I'm honest. I've been banging my head against all with the heat treatment and our business model of doing everything ourselves 100% is the way forward, because buy me some furnaces, Jace, I'll heat treat here in the house.
But of course you can't do that right from the offset, can you? You know, the things that we can't utilise or we don't have the space for, we've had to use the supply chain, and that's been
for the frustrations there, and the small amount that we've used, to be fair.
And then there was the fact that the team had to cope with components that were just plain difficult. Some of these things were just far more difficult than we ever imagined to produce.
When Mark approached me and said I'd be making bearings, I thought he was joking at first, because they are really difficult to make. I realised he wasn't joking, so I was a bit apprehensive, but also excited to try and do a good job of them. So the tolerances on the bearings were very tight and difficult to manufacture. 2 microns run out and concentricity. So it did take a lot of work on some of them, especially the thin wall components. But yeah, we got there in the end.
I think one of the most difficult things that they had to make was a blade liner ring, a simple ring, but it was difficult because it was made out of really complicated material, and it had to be made to incredibly tight tolerances to uphold the blade tip clearances. All the way through the development process, the production guys would be working really closely with Ollie in metrology, and they'd be in and out of metrology at various stages of the manufacturing process to understand how the part was holding up, whether it was holding its shape, whether they'd still got it in tolerance as they were removing more and more material. And they'd work interactively to shape the way they were actually manufacturing the parts, shape the process itself while they were trying to make it for the first time.
Measurement's the key to ultimately being able to achieve everything that we want to achieve in the long run. My role throughout this process as head of metrology has been to make sure that as we're manufacturing parts out on the shop floor, we can gather all the data required and necessary to be able to make sure we can fine-tune those processes to come up with this first turbine.
When you're involved in a program like this, you're usually so preoccupied with the current task, the next task, solving the next problem, avoiding the next banana skin, that you don't have a lot of time to stop and think and worry. One of the things that had been on our radar for a long time was the fact that this rotor was a very complicated assembly with lots of parts that were made to incredibly tight tolerances, and we needed to balance this thing so that it could run safely at 50,000 RPM. Now, balancing it depended on how well all of these components fitted together. If they didn't fit just right, the shaft would be wonky and it would just orbit rather than rotate, and it would have been a total nightmare. So as we approached the period where we'd got the rotor together and we were ready to get it balanced, that was really the very first time that we were going to get a sense of how much of a battle we'd got on our hands to get this thing together and working properly. As an item to be balanced, the rotor's actually pretty awful. In addition to its complex shape and form, it actually has to be assembled, balanced, then disassembled and reassembled in situ in the engine. So you have to be able to hold the balancing and assembly tolerances while you rebuild it into the engine, and that's a total nightmare. And if when we put it back together, we found that the thing couldn't be balanced or it was out of balance, we couldn't run the engine. It was a showstopper. Mark and I went to see Chris the very next day to watch the balancing being done, and quite honestly on the way down I think both he and I were both like a pair of kids waiting for our exam results. We needn't have worried. When we got there, Chris had already got the rotor on the machine, and with nothing more than a pea-size amount of plasticine, he'd managed to get the thing balanced to well within tolerances. It had worked essentially straight out of the box. The amounts of balancing lands that we'd provided were more than adequate to give him enough room to remove material and get the thing spinning as sweet as a nut. And when I look back, I think that was probably the first time that both of us looked at each other and thought, we're going to be all right with this. With 2 months to go, manufacturing were flying through the build. We'd machined and inspected high-grade titanium impellers designed to spin at 50,000 RPM. We'd made complex, thin-walled engine casings from aluminium, steel, and nickel-based alloys. We'd made elaborate fabricated combustors, painstakingly pressed, roll-formed and welded from nickel-based superalloys. We'd machined superalloy turbine discs to unimaginable tolerances, including precision curvic couplings and fir tree blade roots. We'd cast precision turbine blades from superalloy materials. We'd precision ground fir tree roots into our turbine blades and discs. We'd pressed tiny locking clips to secure the turbine blades. We'd cast full ring cooled nozzle guide vanes from superalloys. We'd machined, fabricated and vacuum brazed high-efficiency vane diffusers from high-grade steels. We'd machined intricate dual-orifice fuel nozzles. We'd even made our first high-precision, high-speed bearings designed to run at 50,000 RPM. We'd made the first high-speed gears for the accessory and speed reduction gearboxes. And all of that under one roof from raw materials. With 1 month to go and manufacturing screaming through the production of all of the components, you could be forgiven for thinking we were home and dry. But the reality is we then got to start thinking about the detailed design and the production of the test cell itself, which is itself a really complicated project. Testing gas turbine engines is not a game, it's potentially very dangerous, and we have to be able to execute all of those tests in a safe and responsible manner. So we had to develop a test system that would allow us to do that. Our view was the most pragmatic and sensible way to do this was really to base the engine inside a shipping container. The engine itself is clearly small, and so we could put the whole shipping container along with all of the support surfaces and infrastructure out in the yard where it could be safely contained and all of the other environmental factors could easily be handled. I think it was about 2 weeks prior to ignition when we stumbled across our first major problem, combustion. The complex control and instrumentation system that had been developed on Rufus 1 and was planned for the Rufus 3 test rig and then to be ported straight onto the engine was starting to fall behind schedule. And we were having a range of niggly system engineering problems where you never really know whether it's going to take a minute or a month to solve them and get to the point where the thing is useful. So without a control system, we couldn't run the combustion testing, we couldn't complete the setup of the combustor, and we couldn't run the engine. We needed to change tack. I'd started to form the view that the whole way that we were doing the combustion testing and planning to control both the combustion test rigs and the engine was getting more and more complicated to the point where I wasn't sure that we were going to be able to get that to work quickly enough to run the engine test rig. Now, about the same time, I'd also been aware of a guy for a long time who was in fact a prolific gas turbine engine collector and had amassed huge amounts of pragmatic experience owning and operating ground-based gas turbine engines for many years. We decided to introduce Ian to the team to support the practical hands-on operations of completing the combustion testing, completing the fuel system testing and development, and then to support throughout the engine test program itself. And the results were immediate. We implemented a simple manual control system for both the fuel and the air on the combustion test rigs. We used a mixture of digital and old world analog gauges to allow us to quickly execute tests and come to engineering outcomes. We were able to immediately develop a feel for how the system was behaving and for what we needed to do next. We could run a test first thing in the morning, modify the design by lunchtime, and over the afternoon and evening the guys could remanufacture the next set of components and we could do another test the very next day. Within a week, we'd got both the fuel and the combustion system working well enough to run successfully in the very first GT50 engine. All that remained was to be able to exercise that setup to higher powers and higher operating points as had been needed in the engine test. Over the years while we'd been developing the combustion system for GT50, we'd looked at all sorts of ways of generating that supply of hot compressed air that we needed to feed into the combustor to be able to test it, and they all ended up being complex, elaborate, enormous pieces of infrastructure that were going to cost a fortune and be big and expensive and difficult to make. It had never once occurred to us that we might be able to access inexpensively an existing gas turbine engine that was designed as an air starter for a bigger engine. And as it turns out, Ian had got 3 of them in his garage. So we duly stuck Ian in a van and sent him home to pick up one of his engines that was used to start RB211 engines back in the day. And he brought that up with all of the plumbing that we needed. We made a few adapters so that we could connect it onto the combustor rig. And the very next day, we were ready to start testing in a manner using compressed air from that air starter unit that allowed us to push the combustion system all the way up to the operating points that we needed to prove out for the engine test. It worked a treat. Ian's air starter worked perfectly. It fired up, it pressurized the system, and the harder we drove the combustion system for GT50, the better it worked. The flame was more stable, it was properly contained within the combustor, the recirculation zone did exactly what we wanted it to do, the swirlers worked well, it was incredible. Importantly, the combustion and the fuel system were now ready. And we'd learned an awful lot about how to get this sort of stuff done quickly and pragmatically. You really have to try and leave the complexity out of these sorts of programs as long as you possibly can, and only let it creep back in at the last possible minute when you simply can't do without it. And that's exactly what we've done with the whole engine. With about a week to run, our attention had very much turned to the installation of the instrumentation that we needed for the development engine. And we were literally tearing our hair out trying to get this complex web of pipes and wires and sensors buried deep into the engine.
My name is Eric Welsh, and I support the GT50 engine program with instrumentation and control systems. Given that this is our first engine, we have been intentional to put a lot of sensors and instrumentation in various positions in the engine to assess both the health mechanically of the engine, making sure that the temperatures and speeds and vibration, there's nothing out of bounds there, but also to assess the efficiency and performance of the engine from a thermodynamic perspective. So we're measuring temperatures, pressures, speeds, flow rates, vibration. All of these different things help us form a picture of what's going on inside and gives us the ability to make sure that things are running correctly, there's not any issues, faults, and like I said, measure the efficiency of the engine.
The problem with instrumenting a small turbine engine is you need to get data from sensors that are in areas in the engine that are totally inaccessible. Now, to do this, we have to route a mess of wires and hypodermic tubing from the core of the engine through all sorts of tiny passageways out to the outside world where it can be connected up with the data acquisition system. All of these individual tubes and wires have to be sealed to maintain pressure integrity of the engine, and that all has to be done while the engine itself is being assembled. Just talk us through what that was actually like, because it was a total
Somebody looking
nightmare.
in, Jason, it was messy.
Yeah.
Chris on the table, feeding the big casing down. I think I was one side, you were the other side. You had 3 cables to pull through the casing.
Yeah.
You broke 2, Jace.
I did break 2, yeah. You banned me after that.
Yeah, you banned from the shop floor.
But we'd have to tape extensions to these hypodermic needles, and then you're looking up inside a combustion case that's that big to try and thread a hypodermic needle through a 2mm hole up the side of the combustion case, and it's just...
And Niall come up with a corker with the fishing...
yeah, you shrink wrap fishing.
To extend it, that was,
yeah.
that was great, that worked well as well.
One of the other things that people won't realise as well is that while we've been building the engine for the first time, we've also been having to design, manufacture and then use all of the jigs and fixtures and specialist tooling that we need to put these complex components together. So every time we come to fit a new component, more often than not, we'll need a fixture or a tool to be able to fit it. So the whole process of building the engine has been punctuated by stopping and starting and having to make a new bit of equipment to be able to hold a part in a part assembled condition while you're then feeding the next range of parts around it. And if you take all of the time-consuming difficulty of the instrumentation out of the build, and if you take all of the stopping and starting to be able to develop and use the tools and jigs and fixtures for the first time, you take all of those things out and you just look at what it actually takes to build and assemble a GT50, then what we've found is it will actually take one man about 4 hours, half a working day, to produce a GT50. So scaling up to high volume production isn't a daunting task at all. With about 48 hours to go until ignition, we'd essentially completed everything that we could do with the engine in the vertical build position, and we now needed to roll it over onto its side, get it mounted on the test bench so that we could finish off the last of the assembly. And to do that, we had to bring it downstairs and mount it with the test bench down here with the crane. And there have been 2 slight oversights that we discovered during this process. The first of which was that we built the engine in the mechanical assembly lab upstairs, and we currently don't have a lift. So the only way that we could get the engine downstairs was to get it onto a pallet and wheel it round to the loading bay, and just to very, very carefully lower it down on a forklift and then bring it round to the test bench.
Ed had the honours of bringing it down, and it was a nervous moment. I was a bit of a sigh of relief when we got it down on ground level.
Yeah.
So we all walked round to the bed where we got the crane to lift it from vertical to horizontal. So we were all weighing it up. You were there, the team were there. Ed's standing there, so Ed's been on the forklift, brought it down. Ed's, where's the engine?
Where is it?
Oh, you want me to bring it in?
No good walking around there.
Half a job, man. Come on. And then, of course, it was delivered vertical.
Yes.
On the floor, and
Yeah.
we've got to try and turn it horizontal.
Yeah.
And I think one of the things we all overlooked at the design stage was the fact that it was built vertical, and you've got to turn it horizontal, and we hadn't really provisioned for any proper lifting eyes on it. So
Another nervous moment, that one.
yeah, we'd just tacked some lifting plates onto the flanges, and we've got to get it round without damaging anything.
We did it.
Yeah, but we got it round,
Yeah.
got it on the bed, and I think that for me was the first point that I thought, we've got an engine. And then finally, with about 12 hours until ignition, everything was built, everything was assembled, everything was tested, and it was time to move the engine out to the test cell in the yard. We once again forklifted the engine and carefully manoeuvred it through the walkways in the factory, with one of us on every corner, making sure that we didn't damage anything. For the first few low speed runs, so the lubrication tests, the cold cranking, and then the initial self-sustaining runs, we'd elected to turn the whole test rig round and just have it half in and half out of the container. We didn't need the acoustic deadening for those tests, and it was really important that the team could get in and around the engine during commissioning and during the setup for each of the tests, so that it was easy to work on. So we positioned the engine in that manner, and then started to connect up all of the services, the power, the lubrication system, the fuel system, and everything else that we needed to do with the instrumentation and control to be able to start the testing process. And then I'm particularly proud to say that I was the one that gave the very first GT50 engine its very first drink of Jet A1. With about 4 hours to go until ignition, the test rig and the engine were all connected up. The electrical power supply was connected up. The lubrication system was online. The cooling system was online. The instrumentation, the control system was online and responding. It was finally time to start shaking down some of these life support systems and control systems so that we could start the test program. The first engine system that we'd planned to test was the lubrication system, and that's for two reasons. Firstly, it's absolutely critical that we get sufficient cooling and sufficient lubrication to the high-speed bearings, because if we don't, then the rotor would seize very rapidly and essentially destroy the engine. It's also vital that we get just the right amount of oil in the engine, because counterintuitively, if you have too little oil, the engine, the bearings and the gears will get too hot as they generate too much friction and you can't get the heat away quickly. But perversely, if you put too much oil into the system, that also makes it worse. So what happens is if you've got too much oil in and around really high-speed components, then the components rapidly froth up and foam up the oil, and that causes the gearbox casing to be full of like an oil air foam, which rapidly generates heat through viscous shear and friction against all of the components, and then that mechanism causes the bearings and the gears to overheat. So we're trying to find that delicate balance of just enough to lubricate and cool, but not too much that we start to build excessive oil foam that we can't effectively scavenge, and we then overheat the lubrication system that way. So that was very much part of this early wave of testing, is to get that set up just right. So we bought the air oil heat exchanger online, we bought the scavenge pumps online, we bought the pressure pumps online, and for a moment everything was great. It worked just fine. But before long, Mark noticed that there was a small leak coming from the rear of the engine. It looked like it was coming out of the rear bearing housing.
Leaked everywhere today. It was all over the floor, casing was dripping, it was all over. It was a right mess on it. It was, wasn't it?
Yeah.
I think every possible place it could leak out of, it leaked out of,
Yeah.
didn't it?
By this point, we'd been going for about 19 hours, and I can remember thinking to myself, I really hope it's not going to be one of those days. And I walked round to the front of the engine, and as I looked at the front of the engine, I could see there was actually oil coming out of an instrumentation port right at the top of the accessory gearbox, and it was coming out of the accessory gearbox air oil separator vent. Now, GT50 is a dry sump engine. There shouldn't be any residual oil in those casings. And so the moment I saw that, it was obvious that we'd somehow managed to get the pressure and the scavenge rates wrong, and we were simply just pumping far too much oil in. We were pumping more oil in than we were scavenging out, and so it was just filling up every cavity in the engine. We were essentially force feeding our newborn engine with oil, and it's just not set up to cope with it. So we backed off shut down the pressure pump, we scavenged to clear out all the excess oil in the engine and shut the whole thing down. And then we systematically took off the feed lines and the scavenge lines and did some really simple bucket engineering to physically measure exactly what each of the pressure pumps and each of the scavenge pumps were delivering and returning. And we really quickly identified that we just weren't scavenging what we thought we were for some reason. We'd just got the pump set up wrong. When we worked that out, we were able to very quickly recalibrate them and run the scavenge pumps a little bit quicker, pressure pumps a little bit slower, and that completely rebalanced the system. And so we quickly calibrated that again, then reconnected up the engine, and we went again. While the production team had been diligently manufacturing the last few components and then painstakingly assembling the engine, developing the fixtures and fitting out all the instrumentation, my attention had turned to how exactly we were going to execute this first phase of testing, and how we were going to execute that testing in a way that protected the test engine and make sure we didn't do any damage to it, and made sure that we completed all of these tests in a safe and responsible way. So I'd spent a long time going through all of the potential failure modes that we had to manage, all of the things that could potentially go wrong, and then developing from that a series of procedures, a series of processes, and distilling that down to a series of operational checklists that we could use on the day to be able to execute the tests reliably and safely and consistently with the plan. Right. 2 tests. Yeah. First one, cold cranking. This is really just making sure that we've got no strange mechanical noises, no rubs, and just to get a feel for using the starter generator. Yeah. So the idea is we're going to start it at 500 RPM, and then myself and Mark, we're going to have a little listen, a feel for mechanical while it's going quiet and while it's going slow. Eric, if you just keep an eye on the starter gen temperature, because this will be quite not a long test, but it'll be longer than a normal start cycle, albeit at the bottom end it's not pulling very much. So you call
if we get close to limits, we'll just stop.
Call time stop, let it cool down.
Yeah.
You've got your forced air cooling, so it should prolong that a little. So the other thing that we want to try and get a feel for on that first test as well is that the lubrication system is behaving itself.
Yeah.
So the main risk there's two main risks we've got to avoid: not cooking the bearings and not getting oil leaking into the gas path, because the engine will run on oil. Yeah, and it'll just run away with M1. And you're going to struggle to turn it off then. Yeah. And so if we start to see lots of oil coming out of the AGB, you're not scavenging enough, you've got to turn the inverter side. But we'll do this all very slowly and very gently while we're doing the cold runs.
Scavenge as well when we start them, obviously scavenge first.
Scavenge first, yeah. There's very little volume for oil in the rear bearing housing, and there's only limited space in the AGB case. And if you get too much oil in there, when the engine's running faster, you'll rapidly churn that up into foam and generate loads of heat. Yeah. Right, so with this first, Eric, you set N1. Yeah, so you just play with the voltage until you get to a speed of around 500. And then we're just going to look at everything and then increment it up by 500 RPMs. And then at some point, you'll start seeing a temperature rise in the starter gen, and we might have to break off. And we'll go through that until basically we get to 15-18%. I'll expect we won't be able to go any further with the starter motor. Stop, give the starter a break, and then after that, as long as everyone's happy, we can go on to try and light it.
So what increments roughly again?
500 RPM if you can do it. If you don't have the control, we'll go up in 1000 RPM increments. We're really just listening for rubs, for any misbehavior in the lubrication system, and for any sign of vibration. So just sanity checking there's nothing major wrong mechanically. The startup sequence is the igniter's on, fuel off, and then starter generator. For this one, we want it set at 28 volts, so it just accelerates as hard and as fast as it can. Just
Ka-chunk it.
Ka-chunk it in, ka-chunk it in, let it go. If we get it up and running, I'm going to run it for about 5 minutes. And just keep an eye on the bearing temperatures and the oil temperatures more than anything. Just look for any signs of smoke in the exhaust or that accessory gearbox vent down to the floor, because that's a sign that we're getting out of balance in the lube system, and we're pushing oil or oil mist where we don't want it. And that's it really.
Given that this is the first time running our engine, we took it very conservatively. Initially, just testing all the supporting systems for the engine, the igniters, the lubrication system, making sure that oil is getting into the bearings and gears in the right places, checking the flow rates for everything there, temperatures of the lube system. And from there, we went a step further and started dry cranking the engine. This is just running the starter motor at a low speed continuously, making sure that there aren't any vibrations or mechanical issues, any rubs anywhere. So that's just feeling and listening to make sure that there's nothing wrong from a mechanical perspective with the rotor.
Once again, we bought the oil air cooler online. We bought the forced air cooling for the starter generator online. We got all of the instrumentation operational, bought the scavenge pumps online, bought the pressure pumps online, and then gradually started to wind up the voltage on the starter generator until N1 started to gradually climb for the very first time.
Not long.
And that's not at full voltage.
Yeah.
So
That's about right.
I'm just saying
about like
they're quick enough.
16 seconds.
That feels about right. That sounds about right. Yeah.
Once N1 had stabilised at its first set speed at around 1,000 RPM, Mark and I went and inspected the engine at really close quarters, just looking for any signs of vibration, any strange noises, any indication whatsoever that anything was touching or rubbing or any of the mechanical components were in any way unhappy, and there was absolutely nothing. So before long I was signalling to Eric to bring the speed up again, so he raised the voltage, he took it up again, and we essentially ran all the way up to 10,000 RPM relatively quickly. There was a very subtle rumble at about 3,000, which was just one of the accessory gearboxes, one of the accessory gears rattling ever so slightly because it was unloaded. But we've soon passed through that, and the engine just ran beautifully smoothly all the way up until the point where the starter ran out of power and it couldn't push any harder. The balancing of the rotor was exquisite, and all of the vibration and the rotor dynamic characteristics were exactly what we were expecting. We couldn't have hoped for it to have run any better for a first engine. Then suddenly there's nothing else left to do. 30 years of your life have passed by leading to this moment, and now it's time to see if you can live up to all of those promises that you made. Five, 4, 3, 2, 1.
So I was stood at the side and I could just see Eric, and he just said, "I'm out." And then Jason threw his arms in the air. And then that was it, self-sustaining.
I don't think I'll ever be able to explain how much of a big deal it was that it just worked, that it just worked out of the box.
I just remember looking at the screen, it was like 27,000 RPM.
That was an incredible moment to be a part of. It was surreal almost, because this program has been going on for a few years. We've all been looking forward to this day to see this engine running, and to be a part of it there for the first time was an amazing experience.
We've done a 23-hour shift and everyone was on their knees, but the adrenaline and the moment just got the better of them. It was great.
That moment, I don't think I've ever felt more alive in my whole life.
I didn't really know. We weren't planning to have it self-sustaining that night.
No.
And I think there's something very poetic about the engine taking its first breath as the sun came up at 3:51 in the morning after such a monumental effort from everybody involved. That's special.
It was special.
That's special.
Live with me, that one.
The vision and goals for the Hill movement were inspired and empowered by over 1,000 private aviation pioneers that believed, like we did, that general aviation can be much more than it is today. These people backed us when most thought our task was impossible.
I'm Peter Wilson. I'm an engineer by background, and in the recent years have been flying long range. I met Jason Hill right in the early days. I think it was about 2020, so about 6 years ago, and I've ended up with serial number 31.
I'm Mike Lord. I am a Hill customer, serial number 6, and I have got a lot of experience of working in manufacturing industries, product design, and getting mechanical products to market, which are somewhat simpler than a helicopter. So I'm serial number 6, and therefore I was very early on, and I think that's 2020 probably when I got involved in the program.
A significant event. This is fantastic because each turbine has its own signature as you start it, and to see the GT50 start for the first time is unbelievable almost. We've been waiting for it for a long time and looking forward to it, and to just see it so effortlessly come to life is fantastic.
Seeing it run and realizing the milestone, such a significant milestone on the dream of flying a HX50 was amazing. I felt privileged. It was emotional to see that first run and to get the roar of the jet engine at the same time as feeling those emotions was just great.
GT50 will have a significant impact on general aviation. We now have a powerful turbine at a great cost point, going into a great helicopter in the first instance, and it's just going to make flying available to people like it hasn't been before.
As Hill continues to go through the milestones of this project and continues to impress with its capability and its cost base and all the vertical integration that allows them to bring a helicopter to market getting on for half the price of what anybody else can do, is just going to change general aviation and everybody's mindset about what these things should cost, and open up that market to just so many more people who currently can't have access to that market.
With such a vast scope of work, our commercial strategy to date had been one of responsible prudence, maintaining a laser focus on our core offering while being financially prudent in the face of significant technical uncertainty to make sure that we got there. We kept a minimal staff count, compressed our overheads, and afforded ourselves only that was absolutely necessary to ensure we met each of the key technical milestones. We traded off the security of delivery with time, and it worked. We delivered. Now, with a functioning GT50 in existence, our operating environment has changed profoundly in our favour, and so can our strategy. Our focus can now shift to getting our products into the hands of our customers as fast as it is safe to do so. It's time to accelerate. To get our beautiful aircraft into the hands of our customers sooner, we can now accelerate the development of HX50 and GT50, accelerate both our organisational and aircraft approvals, and accelerate the build and production of the Hill Global Production Centre. Carrying out these activities faster means growing the team. It means investing in key pieces of equipment sooner, building out infrastructure sooner, and doing as much of that as possible in parallel. Our plan had always provided for this, but to date, responsible prudence had led us to delay expenditure until all of the key technical risks were mitigated. With the first run of GT50 now successfully behind us and first flight only a matter of months away, we can now afford to be much bolder. We can spend harder and we can deliver faster. The ideal way to deliver this is to access a small amount of cash flow from our existing order book. Tonight, I'm going to outline a range of opportunities for customers themselves to drive program acceleration and get their aircraft sooner. The single biggest lever that we have to enable us to get our aircraft into customers' hands sooner is simply to make them faster, make more of them. We've always had this option, but the challenge is that there is no market data from recent decades that supports the long-term production rates of more than 1,000 units a year for light helicopters, and even maintaining this level is ambitious. Consequently, you simply can't justify building a production capability for more than 1,000 units a year for a single light aircraft or light helicopter product line. However, there may be another way, Our unique approach to manufacturing has built a general aviation manufacturing platform. We can build any light aircraft, not just helicopters. Once HX50 enters service, our business plan pivots to producing similarly disruptive light aeroplanes and larger, more capable helicopters. And that might just be the key to temporarily increasing the production rates for HX and HC50. Once HX50 is in service, the next product from Hill will be AX60, our 300-knot, 6-seat, GT50 powered pressurized aeroplane. Priced comparably with HX50 and using our existing manufacturing infrastructure and technology, AX60 will rapidly be brought to market using our proven dual roll approval model, just as we've done with HX50. Importantly, AX60 is also a 1,000 unit a year product, meaning shortly after HX50's service entry, we'll need a capacity to produce a combined volume of 2,000 aircraft per year. Subject to validating the interest in AX60 over the coming months and subject to the continued flow of anticipated sales for HX and HC50, triggered by the first engine run and first flight milestones, then we'll build the Hill Global Production Centre to rapidly scale production up to 2,000 aircraft per year. In the first 3 years of HX50 production, the entire production capacity of the facility can be allocated to HX50, giving us the potential to massively increase output as the expected orders arrive. GT50 is the heart of HX50 both technically and commercially. Over the last few years, we've defied the odds and built the first new helicopter turbine engine in decades, in addition to all of the manufacturing facilities to produce it affordably. We are now the only company in the world able to drive purchase and operating costs for general aviation aircraft down to a level that will completely revitalize the industry. With 1,457 aircraft sold, a further 5,000 orders pending in the sales pipeline, a proven ability to manufacture, build and successfully run the GT50 engine, there has never been a better time to join the GA 2.0 revolution. The potential increase in production capacity to 2,000 units per year dramatically reduces waiting time for those that are prepared to act swiftly. The current list price for HX50 is $675,000. You can purchase a HX50 today under the pre-order program for £578,000 with a £30,000 deposit. The current list price for HC50, our certified model, is £795,000. You can purchase HC50 today under the pre-order program for £657,000 and a £50,000 deposit. To celebrate the first run of the GT50 engine, the Elevate program is available to new customers for the next 30 days and closes at 3:51 a.m. on the 20th of August. During that period, new customers can purchase HX50 under the following special conditions. The list price of $675,000 is discounted by £92,000 to £583,000. For an increased deposit of £50,000, your aircraft will be fitted with the 4-axis autopilot or emergency pop-out floats free of charge. This offer provides an instant increase in value of your aircraft and adds significant additional safety features for no additional cost. For more information, go to hillhelicopters.com/raisingthestandard. For existing customers, we're today announcing the Raising the Standard program. You will benefit from £50,000 worth of free optional equipment by bringing forward a £50,000 additional payment against the base price of your aircraft. You'll get the 4-axis autopilot as standard, and you can choose from either blade fold and heli move or the emergency pop-out floats. This program is strictly limited to 30 days from the first engine run and closes on the 20th of August at 3:51 a.m. For more information, go to hillhelicopters.com/raisingthestandard. At precisely 3:51 a.m. on Monday the 20th of July 2026, as the sun was coming up over PC1, GT50 prototype number 1 took its first breath and roared into life. Surrounded by the doting engineers that designed, manufactured, assembled and commissioned every part of her. The aviation renaissance that we promised is now here, and today dawns the age of the affordable turbine aircraft. Welcome to GA 2.0.
Welcome everyone. Great to have so many people connecting in this incredible moment. I think we have absolutely a record of attendance today. Jason, this is a special moment. Misha, also, what a moment to be alive here for General Aviation. We went through this story of how everything was built, and we have the first question in line. But before, one that is very, very asked to Jason is, what about the capacity to do all this? What is the financial situation of the company? What are the plans? And how you're actually planning to scale up, as you described, with the amount of aircraft we need to produce and would be bringing to the market?
Thank you and welcome everybody. Yeah, the plan has never changed from day one. We've always had an extremely strong financial position, thanks very much to the strong orders that we've had throughout the program, and that situation remains even to this day. As we've grown in capacity, as we've sold more helicopters than we've ever expected to, then we've had to adjust upwards our projected production capacity rates, and the strategy that I've outlined this afternoon is very much just a natural extension of that. So we remain in the position where we've always intended to use commercial sources of finance, normal commercial sources of finance, to scale up the huge production facility that we need now. We have advanced offers along those lines on the table and available to us, so I really don't anticipate any problems or hurdles in being able to build a factory for either 1,000 or 2,000 aircrafts per year. And it's really now down to the aircraft buying public to tell me how many they want. If the orders continue to be as strong as they have for HX and HC50, and there is some indication of interest that we've got it right with the fixed wing alternative that will only follow long after HX50 has entered service. It's not a distraction, it's just an indication of how we're able to justify such a capacity for a factory. Just a little insight of what's to come over the rest of my life. So commercially, we remain very strong. We're very, very excited about the future. And for us now, it's all about acceleration. How can we do this faster? How can we get it into the hands of our customers that have trusted us to deliver this?
Awesome. We've got lots of questions here today. Welcome, everybody. It's good to have you guys back. We're going to go through the first question here. Ruben got the privilege of having serial number 1 for HX50. Jason put me down for serial number 1 of the AX60, and I'm gonna have to get my fixed wing license in the meantime, but I'm definitely looking forward to that as well. The first question is from Steve, and he's just asking about certification. So for the UK CAA certification, what are the remaining certification gates? So timelines, key risk mitigations for both the GT50 engine as well as the airframe.
I think the key thing to focus on now is really what we've got to do to validate that the engine works, and the certification program and the compliance showing follows that. So the GT50 approvals program, both from our internal engineering perspective and then externally, follows a sort of 10-phase plan. The first 2 phases are complete. We've just shown you them, which was to get the engine together, sort out all of the build issues, get it running all of its systems and accessories properly, and then to get the thing cold cranking on the ground, validate the rotor dynamics, and then to get the thing lit and self-sustaining. Tick done, it all worked great. The next stage now is to push the core of the engine all the way through its operating range, and as we do that, we can then determine whether or not we've got the compressor and the turbine matched properly, and just tweak the nozzle guide vane areas as required to get those things working exactly as designed. Once we've done that, we can extend out to look at acceleration and deceleration rates, and once we've done that and we're happy with all of that, we'll do the first certification type endurance test. So that's basically the qualifying endurance test we have to do to meet CSE or Part 33 in the US, and that will be an internal version of that test for us to prove to ourselves that we can meet it. Once we've done that, we'll then put the drivetrain on and repeat those exercises. Then we put the on-engine accessories on and run it with everything that you'll see in the helicopter on it. And then finally, we'll repeat all of that with an engine with slightly less instrumentation that's representative of what we're going to put in the helicopter and what we'll be delivering to the customers. So those are the stages that we're going to go through. As we go through those stages, the authorities will be very heavily involved in witnessing those key tests. And then the final stages of that is the ground running of the aircraft in the engine, the flight testing, and then finally the long-term endurance testing that we'll do with the type conforming engine that will be running for a good 18 months from now.
Okay. Great. Also related to validation, what about the international rollout? Can you give more details about the international rollout in different countries, specifically EASA, FAA, and all the other overseas territories that we have sold aircrafts?
Again, the strategy hasn't changed from day one. So our state of design is the UK. So for both HX and HC, we're working with the UK CAA to start with. That allows us to get all of the compliance showing materials to the right standard. It gets our certification plans agreed with the authorities for both X variants and C variants and both the aircraft and the engine. Once we've done that, then depending on where you are around the world, the UK CAA has bilateral agreements with some organisations where foreign authorities will just have to do a type validation. So just essentially signing off on the certification that's been done by the UK authority. In other territories, the authority will want to do more of a parallel certification. And then for for the X products, we'll be going around each of the national authorities to get the UK approvals ratified. And then for the X, for the C, the certified version, it depends on whether it's a bilateral or whether it's a validation exercise. So we'll be doing that. I think 80% of our customers are in 7 territories, so it's not quite as big a task as it sounds for the majority of customers. So we hit those states first and then work our way around the others in delivery order for customers. Hill takes full responsibility for all of that. So for the people that are with the X side of the product range, then we handle all of that for you. It's not left to the customer.
Very good. Also for the engine live testing, so the telemetries that you're going to be able to get, is it feasible for the owners to be provided with like a special private dashboard where they can view all those things in real time, possibly the engine running in real time, etc.?
It absolutely is, and we will. But the early stages of testing aren't an interesting thing to watch, and you'll be able to give the best account of this, Misha, because for the people at home, that very concise review of what we did for the first run, the exciting bits that you'll all have enjoyed played out over 10 minutes in the video. That was a 21-hour day. And most of the day you're trying to get stuff connected, you're trying to get stuff to work, you're taking things apart and putting them back together again. And I think we wore you out, didn't we, Misha, before we actually got the thing to run. You just saw all the problems. And so it's not exciting to see the reality of these things. They're very methodical and quite tedious things to watch if you're not intimately involved with doing the act of testing it. So the time to watch the instrumented tests will be when we're doing the endurance test, for example, when we're blatting the thing for 150, 175 hours. And then once we're on the bench doing the life extension testing and the thing's on test for 5,000, 10,000 hours, then when we're doing those ones, then of course there'll be a live dashboard. You can see the hours clicking up. You can have a look at some of its vital signs and that, and we will do that for the customers for sure.
Beautiful.
What is the current involvement? What is the current flight test roadmap, and what is the involvement of any? If I think you have alluded in the past the involvement of the Royal Air Force on test plan, and what is your plans on that? Can you give more information about the roadmap and what is the flight test details that is coming up soon?
Certainly, again, the plan hasn't changed. I've never said anything about the Royal Air Force. They don't have anything to do with commercial flight testing. I may have alluded to test pilots that are qualified by the Empire Test Pilot School, and it will be certainly one of those guys that comes and does it. But all of the test flying will be handled by our in-house team, as has been the case with everything else that we do. We haven't actually appointed a company test pilot yet. We'll be dealing with that between now and the end of the year. The UK CAA have appointed their test pilot. He's a very well-known guy. And he's been up to meet us, and as we go through the remainder of this year and turn our focus back towards the airframe again, there'll be more and more details rolled out about that then. But test flying will be done in-house by our people, by our team, because that's a function that we'll need for many years to come. So no change there, it'll all be done by us.
Okay, great. Next question is from Antonio, who owns a couple of positions in the 100s serial number range. And he said, could you please touch on the latest iteration of the projected timelines between now, 2026, and 2028? What will be the milestones, and when could the different tranches of the HX50 and HC50 positions be expected to travel to, for us to travel to the UK for the build, delivery time, training, all those types of things?
Yeah, so for once, there's no major change on this. We're actually in a very good position with timeline. So the current plan for the engine is we think we can have everything up to about phase 8 of the test plan done by Christmas. So we'll have, assuming everything goes well, of course, this is engineering, but assuming everything goes to plan, we expect to be able to have the engine performance testing, the endurance testing, and then a conforming type engine, so the flight engine on the bench with its endurance tested done by the time we get to Christmas, ready to start ground testing the airframe. I think in reality, the first flight and the ground testing of the airframe will push just into the new year, but not by very much. So I would expect ground testing to be happening around the February time, with first flight sometime in April. In terms of the remaining approvals and the start of production, at the moment I don't really feel it necessary to change any of those timescales. I think we're still in good order for that. So all of the delivery times and the production start times are about where we've anticipated them for the last 6 to 12 months.
Okay. And is the engineering demonstration of how the engine rotor Cowls panels are going to be opening, and how is that going to be accessible, is that available already, or do you have any plans that are available that could be checked out, that people want to know how this opening is going to work of the Cowls?
Absolutely. So we've been teasing for a little while that there's a whole host of work being going on the aircraft behind the scenes. There's a lot of exciting upgrades on the aircraft that will be rolling out shortly, but I haven't put any of that out into the public domain yet, because I didn't want it to be perceived as a distraction from what's been considered to be the major technical challenge for the program for a while, which is the engine. So the next AMA will be squarely focused on HX50 and all the development that we've been doing behind the scenes on that. So you can expect a major update on the new structure, the new drivetrain, an update on where we are with the rotor system, the flight control system, the digi-cockpit, the interior, the crash-worthy seats, the tail rotor, all sorts. Everything you could possibly want to know about the airframe will be coming in the next AMA. So there's a lot of information to share on that, but today's not the day for that. We're going to cover that in the next AMA.
Okay, very good. Next question is from Tony. By the way, I've been getting multiple messages coming in here in the meantime of people putting their names down on the AX60. So I think a lot of people are very excited about it. So that's good. And we'll be talking more about that in the coming weeks and so forth, about when things are going to be opening up for that and pre-orders, etc. But the next one from Tony, it says, there is a significant interest in new sovereign gas turbine engines for defense use. So do you see the GT50 being adapted for non-hill purposes?
My mind is open to those sorts of things. There are certain applications that we would entertain as a company, and certain strategic things that I think we have a responsibility to do. The GT50 and our engine technology suite is very much the crown jewels of the company, and so the way we exploit the engine will be to put the engine in many different types of our aircraft over the rest of my working life. This isn't necessarily a quick thing, but that's the way to build the aviation business that I've always wanted. For non-competing applications, there are areas of aerospace that I'm not interested in putting products into, and for those areas we would entertain it. So I'm not all that interested in autonomy, and I don't see us doing that much in certain other areas as well. So our ears are open. If people want to contact us for potential applications for GT50, feel free.
Hill's interest in aviation is fun aviation, right, Jason?
Yeah.
Autonomy.
Yeah.
Fun. Make it fun again. Well,
we make toys.
Now we have the next one. Exactly. This one is you have used outside resources for heat treating. Is the intent to bring all of this in-house? If not, what are the outside resources that will be used in the course of production?
We will bring absolutely everything in-house. I've got to be careful how I describe this. One of the most challenging parts of building this engine is the fact that so many of the components have 30 stages in them, and it only takes 3, 4 or 5 of those stages to involve an external subcontractor, and your time scale to manufacture it multiplies by a factor of 10, because you've got to, when you've completed your stuff, send it out to somebody, wait in their queue, let them do their thing, then it comes back to you, then you've got to resynchronize it with your product, and then out and in and out and in. It's impossible. It's impossible. So we will manufacture everything ourselves here, and every part of the process will be done by us. So heat treatment will be done by us, plating will be done by us, everything that we need to make this aircraft will be done by us.
Okay. Next question is actually a really fun one, Jason, because you described this to Ruben and I just a little while ago, and it's neat to see what's actually changed, so what the progression has been. But this question is about the transition in design for the GT50. So it says, Jason, when you launched Hill, you said you had an engine design from your original company that you were working on back then with Dynamic Engineering. So how close or how far away are you from that original design of the GT50 to where you are today?
Honestly, it's completely unrecognizable. The original, you can probably remember the old renders that we did. The original engine had got, the compressor is basically the same. The compressor, the rotating part of the compressor is the same. Everything else is different. So we've still got a single stage compressor. We used to have a 2-stage gas generator turbine and a 2-stage power turbine. They're now both single stages. They used to be cast one-piece blisks. They're now forged discs and individual blades. We used to have 3 can combustors. We've now got a 12-channel annular combustor. We used to have an oversized vane diffuser. We've now got a very compact, high-pressure diffuser. The fuel nozzles have changed completely. The fuel control system's changed completely. The bearings have gone from things that we were hoping to outsource to our own designs and have changed completely. The power turbine has gone through several iterations and is completely unrecognizable. The drivetrain's totally different. The structural design of the engine and how we mount it's totally different. The way we manufacture most of the parts is totally different. What else have we changed? I think about the only thing that's still the same is the name.
Could you compare this a little bit to the progression of how SpaceX did with the Raptor?
Yeah. So
look at the initial Raptor,
the main
complex and big.
The main
and then it's simplified down to something.
Yeah, the main thing we did when we started is we tried to design the engine in the lowest risk way we could from a technical standpoint. I mean, seriously low risk. This was almost an industrial gas turbine when we started. So can combustors, for example, and so on. And what happens is, as you go through, more and more of these features get deleted and you find ways to make it simpler. It's more complicated to design, but the net result that you finish with is simpler, less parts, lighter, smaller, and so more reliable. And so the engine looked very much like a Frankenstein engine when we started by aerospace standards, and it's just got cleaner and simpler, and more of the parts have been deleted. We've gone from 4 turbines to 2 turbines. The diameter of the engine shrunk, the casing design simpler. So it's gone from looking like a Frankenstein thing covered in external pipes to a very clean, simple engine. And that thing that you can see behind me, or of all the things that are stuck on the outside, 90% of that is instrumentation for development, and almost all of that will disappear in the production engine. It's such a clean looking engine on the outside. All the SAS system is now routed internally. It's just far more elegant than it started. One of the features that we have kept from the original design is the rear power takeoff for the power turbine. And if I could start this again, if I could have my time again, I'd delete that and I'd go concentric shaft and go straight through the middle. But at the time, we thought that the rotor dynamics and the bearing design associated with that would be too risky to do as a first engine. And we've subsequently had to get really good at that anyway. So if I could have my time again, I'd have done that, and that would have taken some further weight and complexity out the engine. And made some of the installation issues with the engine, with the aircraft easier as well. So it's changed a lot, but that's design, right? You start with a blank sheet of paper, then you find sort of intellectually the simplest way to solve the problem, but that isn't necessarily the simplest way to design the product or to make it. And so you iterate and iterate and iterate until you meet all the requirements, and that's pretty much where we are now with the engine. It's a very, very, very nice, simple, inexpensive, and it will be proven to be reliable little engine. So we're delighted with where it is, but it's been a battle to get here.
First question from Carl. Carl has a couple of good ones here. First one is, what does the new fuselage look like? What has been changed? New door locks, small pillars, added places for floats. What is the schedule for the new hull build?
Okay, so I'll set you a challenge.
You can't say
Carl.
Everything, right?
I'll set you a challenge, Carl. If I show you a picture of the new one, if you can spot what we've changed, I'll buy you a beer. Okay, so externally you won't notice. Yeah, externally you won't notice the differences. There's one obvious difference that I'll save for the next AMA, but aside from that, I don't think visually you'll notice the differences. In technical terms, everything has changed. So the main rotor gearbox is no longer mounted on the roof, it's mounted on the engine deck just behind the cabin. The door line has been lifted up, we've got far more crash structure under the cabin. The way we route the flight controls has changed. We've changed the fuel system substantially. We've changed the way we mount the horizontal stabilizer. The way we mount the crash-worthy seats has changed. The way we mount the cowlings on the toppers has changed as well. I'm trying to think of what else the big things are. The way we mount the undercarriage, the wheels in particular, is completely different to what it's ever been. And all of these things have been the gradual process of refinement, optimization, lots and lots and lots of sophisticated crash simulations, competing tensions within the team for different system packaging. So things getting moved around just to accommodate the other systems more readily. So lots and lots of stuff has changed, and I think you'll find, well, I can say wholeheartedly that we now couldn't make this helicopter any simpler or technically more elegant than it is. It's really, really, really well configured. So we're racing through getting that finalized now. We think we're going to be in a position to release the new tools for the fuselage in about 4 to 6 weeks, and then we'll be running at 100 mile an hour. So the guys will get a couple of weeks off in the production crew now after the engine, and then the very next thing they're going to come back to is a mountain of airframe work to do to get the structural test fuselage done and then the ground test fuselage done.
Okay. Just want to add that actually this whole AMA, Misha's one, this whole AMA was engine, but people will see, that the incredible amount of work has been done in the helicopter in parallel has been amazing. So it's not because it was not shown today. we don't want to give the impression that the helicopter has been on standby, the rest of the helicopter.
No,
Completely different. As Jason described, it's going at full speed, and today's AMA was just a dedication to this special moment. But you'll be seeing the next one, as Jason said, it's going to be a lot of details of how things are being worked out.
And the important thing to remember is everything we do is really complicated, isn't it? So to be able to explain it properly, you need to provide the visuals. I need to be able to show you the CAD models. I need to be able to show you exactly what we've done, what it used to be, what we've changed it, why, show you the simulation. So we need to dedicate some screen time to that. Otherwise it'll just go in one ear and out the other. Let's keep this one on the engine, and I'll fill your boots with the helicopter on the next one.
Very good. Jason, the next question is actually for me. This is a personal one. I'm looking out the window right now, and there's a lot of smoke out there. I can't even see the mountains because there's so much smoke out there. There's a lot of fires around here. I don't know if this is the right time for you to touch on engine performance. I know we got some exciting things to announce on engine performance, but as far as a cargo, utility, long lining, water bucketing, if somebody could have a helicopter at this price point, especially with the operating costs of the HX50, or in this case HC50, but be able to do some really incredible utility work with it, somewhere in the ballpark of 1,000 kilos, a couple thousand pounds on the hook to be able to water bucket. I think the impact on the industry from a price point of view would be incredible for fighting forest fires.
Yeah.
Do you want to touch at all on engine performance? Or is that for another future AMA?
It's for a future AMA, but I can make a few relevant comments that will help people understand some of the things that we're doing and why. So I think the thing that you have to understand is we've set out to design a helicopter that's safe in the hands of inexperienced owner operators, and one of the most important things there is power, making sure that you never run out of power. And we've got customers in over 62 countries, and many of them are hot and high. So we always rated the performance of the engine internally, and we always rated the performance that we're offering in the helicopter based on being able to deliver that 500 horsepower all the way up to 10,000 feet on an EASA plus 15 days. That's about 12,000 something feet pressure altitude on a standard day. So if you can do 500 horsepower at that density altitude, then down at sea level you can produce about 720 horsepower. And so just with that metric, there are some opportunities for capability that are not relevant to HX50, but will be relevant to commercial versions of the helicopter in the future. The other thing that you need to understand is that GT50 isn't an engine, it's an engine platform. And so GT50 is right at the beginning of its growth cycle, and if we want to pass more mass flow and push more fuel through it, if we want to wind the temperatures up a little bit, we can, and we've got the headroom to do that. So if I needed to double the power in HX50, I could do that, and I could do that relatively quickly. So that opens the door to all sorts of opportunities for us in the future. But remember, you can't just put more power in a helicopter because the drivetrain has to be designed to withstand it. You need the blade area and the rotor to consume it, and it's not as simple as just putting more power in. But both the aircraft and the engine have got significant growth margin in them. And because we manufacture everything, we can do whatever we like with them.
What a key moment. Future aircrafts, they require more power. Just make it some tweaks, and we have the GT50B, GT50C, right? That's what you're alluding to. Very good. Carl is saying, well, awesome first run. Wow. That's good to hear, Carl. You liked it. And he's asking how long will it have the power turbine now? The next section.
So, as I said, the next section of the testing is to take the core and to work that all the way through its operating range, and that's going to be happening this month. So we'll be pushing the engine all the way to the equivalent of 720 horsepower, getting it matched, getting everything working properly. And then as soon as we're satisfied that the core's right, as soon as the core has passed the endurance test, because bear in mind, we don't just sit there and test it and then bolt more stuff on and then test it. We've got at each of these key intervals, when we've worked the engine really hard, we need to do a strip down inspection, and that tears up all the instrumentation. So there's a very methodical process to add these bits to the engine. So the GG testing, the PT and drivetrain testing, and then all of that will be done ahead of when it's required at the end of this year, unless we find any major problems, which the way I feel about this at the moment, I'm really not expecting any major showstoppers. I think we'll end up tuning some parameters, tidying up some little details inside the engine, but I think it's just going to work pretty much as we've expected. So expect all of that within this year, ready for ground running.
Okay. Next one's a fun one. It says, remarkable story. Let's get this into a documentary. I have a film fest on September 5th and would love to submit for the show. It's at a local international airport hangar film festival.
So, right, let me stop you there for a minute and just make a really important statement. So, I think this whole production here has been really nicely presented and really slickly done, and I'm sure from the outside it looks like it's very easy to throw together, but I think it's worthwhile people understanding how much goes into producing these things. So when you're producing a documentary, you can't really start until after you've done all the stuff, and the moment you've done all the stuff, your sales team say, right, let's have an AMA tomorrow. And it leaves you with a very compressed amount of time to put these things together. And inevitably, I spend a little bit of time having to write these things so that the technical storytelling makes sense. But I'd like people to understand that I came back off holiday on Saturday last week. And since then, Niall, our videographer, our director-producer that produces all of this stuff, he worked 19 hours on Sunday, he worked 19 hours on Monday, and last night he was at work for 10 o'clock in the morning, and he's still here now. So it's taken an absolutely superhuman effort for Niall to produce this. So he'll be delighted that people are pleased with the outcome, but I really need to give Niall a massive shout out because he's absolutely awesome and he's done an amazing job of putting this together for us. And I'd also say those last couple of slides last night, there was 2 or 3 slides that we shot at the end of last night, and on the video they came out in 2 minutes, and we filled an hour and 20-minute data card with all of my misspeaks and my mistakes because I was tired as well, and the guy was exhausted and he just stood there and kept doing it politely, gradually sinking into his seat looking more and more exhausted. So a big shout out for Niall. I think he's asleep face down somewhere at the moment.
Yeah. He's in the baggage bay of the HX50 behind you.
Niall is part of the legacy of this whole thing. Incredible. Thank you, Niall. Next one is, what is the status of the Cresswell site? Is that still planned to be used in the future, or is it at that end?
That site remains an open opportunity for us, so we still have a planning application in there, so the site remains open to us.
Okay. Fun question for you, Jason. It says, given the Raising the Standard program that you just presented, what would you choose yourself? So as far as the options, which one would you go ahead and choose?
I very rarely fly over water, so for me it would be heli move and the 4-axis autopilot and blade fold. And I think, but that's very much a personal choice. You guys spend all your time over water, so the floats are important. I reckon Carl's going to choose the heli move as well. I can't see him having floats.
Carl doesn't want floats. There's no way.
No, I'm a wheels and a heli move guy.
Yeah. For me, there's no way of flying over the water or without those floats. Like it's unbelievable.
We'll get you some armbands.
Yeah. All right. The next one is what is the testing schedule? I think we covered this. So the power turbine to be integrated with the gas generator. So how long do you think that? Just briefly, how long do you think it's going to be that testing phase of that integration once that comes very soon?
Very, very low. I mean, you've got to understand that You've seen the drivetrain, the gearbox, or the powertrain. That's built. I've got 2 of those upstairs waiting at the moment, and we're pretty happy with the way that performs. The power turbine itself it's about 7 major components. It's very, very, very simple. It's a windmill that sits in that exhaust. So I don't imagine that's going to cause, there's very little instrumentation in there. I don't imagine the testing of that's going to cause us any dramas. The rotor dynamics for that are much simpler than the core of the engine. So it's not a big deal. The convenience of testing the engine in this state first is we've got a really convenient way of driving the engine to different operating points using a convergent nozzle. So the exhaust that you can see on there at the moment was really just for the first run so that we could see all the way through the gas generator turbine and into the combustion system in case we had light-off problems, and that proved to be really, really useful. And then we've got a convergent nozzle that allows us to set the back pressure on the rest of the engine and drive the engine to some really demanding operating points. That goes on next, and we work the engine that way, and it allows us to get the engine set up much, much faster. So get that cleared off first, and then the PTs are relatively simple tasks to follow on later. And by that point, of course, we know that the core already passes the CAA endurance test. So it'll be plain sailing at that point.
Great. Next question, I'm not sure if it's a touch early for that, details like this, but any idea on the point, at this point, about the pressurization differential of the AC60?
No.
What would the cabin altitude be at a normal flight cruise altitude, etc.?
I'm not going there at the moment. We haven't done any development on it. We won't do any development on it at all whatsoever until after HX50 development is complete. The only reason for introducing that this evening is purely so that people understand with that roadmap, and given that the delta in cost for building or setting up a factory that can grow to 2,000 units a year versus one that is maxed out from a space point of view on 1,000 units a year is very small. And so if we have enough expressions of interest in AX60, it gives me the confidence to build a bigger factory, which then allows people to receive HX50s and HC50s sooner in bigger volumes. So other than the key, what I'm trying to elicit at the moment is, from my point of view, an AX60 is the perfect partner product to having a helicopter. You go from state to state, or from our point of view, you go anywhere in the country in your helicopter, but if you need to get into Europe or if you need to cross states, a helicopter's not going to cut it, it's just too slow. So you need to go above the weather, so IFR is easy, and you need to go fast. And so we'll be making a fixed wing product with the same attributes of HX50 that gives the performance, the cabin environment, and the user experience. But none of that gets touched until after we finish what we're doing. This is purely for me to understand whether, whether I rent a 500,000 square foot box or a 1 million square foot box to give me the capacity to build more of those helicopters over the next few years.
That's clear. Next one, Misha and Ruben, give us details of the HX50 around the world tour, start location, route, duration, start date, and relation to the first flight certification. Well, we can give you some more details now. We're getting very close to that. So yes, we have talked about this. We are starting that planning. We are thinking of staying around the factory, around the hill for the first couple of months. And then once Jason tells us to go, we're ready to go. We'll wait for his go. We will go. And we're thinking of going around Europe initially, some countries in Europe. Probably not all of them, because the priority will be then to cross to North America as soon as possible. We're going to be spending some good time in the US. Probably going to be in every single. Going to have, so probably half a year there flying in the US. It's going to be a long endeavor for probably about 2 years of a round the world trip. It's going to be a different one from what we did. We'll be spending time to demo the aircraft. So it's not anything about, it's not going to be related to our previous tour. It's going to be about the demo of the aircraft. We'll be staying in locations, bringing clients, bringing prospects, having that test flight opportunity. We're going to have 3 aircrafts, and those 3 aircrafts are going to be the full crew of that team is going to be between 12 and 15 people. So quite a logistics effort, and we started to plan that in quite a detail. And then going probably to South America, and after doing South America, come back again, do North America a little bit, Europe, and then going to some parts of Africa, and then going up again to Asia, and then Asia, going to Oceania. Probably Australia, New Zealand is going to be at the end. It's going to be about 2 weeks tour, and then we stopping, going to the family, back to the family again. Most of our family's going to be with us anyhow. My daughter, my wife as well, and Misha's wife, and also the kids going to be on this tour. So, but the rest of the team needs to go back, and we're going to be having some breaks. So that's a little bit of more details about our trip, and looking forward to that a lot, especially to show you this aircraft in your location. We're going to have a page for that as well. I'm going to ask the world to ask us to tell us where we should go. We'll look at the top. We'll go there first.
And while you guys are doing that, I guess I'll stay here and build loads of helicopters, will I?
It's better,
Yeah,
Jason. Sorry, it's better.
Don't worry about me.
Yeah,
We'll
we
try
plan to do
that
this
too.
right away at the beginning of the production. So right after we get our helicopters, right after we'll be starting that, about a couple of months of that.
Yeah. The paint
Misha's
won't
one.
even be
Go
dry.
ahead. Yes.
Jason's got too much FOMO. We'll have to fly him out to some of these locations and give him some tours around. It's going to be nice. Jason, it says, what major things are left to do besides the engine? What parts of the airframe need most work?
The airframe's in pretty good shape. We've got some exciting news on the rotor head that'll be coming as part of the subsequent AMAs. So there's a lot of work going into that at the moment. We've substantially improved the rotor head. We've got some, because our autopilot system has been designed from the ground up, we can integrate that within our flight control servos. So there's a lot of detailed work going on at the moment with the flight control servos, because we have a single module that includes the hydraulic jack, an independent SAS actuator, and then the autopilot electric actuators that move the flight controls. So unlike some of the retrofit systems, the SAS system is invisible to the pilot, so the stuff that gives you your pitch, yaw, and roll damping is invisible. It doesn't move the flight controls. It's only the autopilot functions that move the flight controls. There's a lot of work going into that at the moment. There's a lot of very detailed work going into the kind of work leading into the compliance showing structurally. So lots of material testing for the new fuselage. We've just done some crash testing on the new energy absorbing structure that lives underneath the new fuselage floor with great results. We're doing a bit of a weight down exercise on the fuselage as well at the moment. We've completed a load of work on the new doors. So new doors, new door seals, new door locks, new door cards, central locking, all those sorts of things are nearing completion now. There's a small tweak to the tail rotor. We've significantly reduced the drag of the duct on the tail rotor and improved the performance of that. Those are the main areas really. The blade work is quite advanced but needs to be adapted to the new rotor hub. And then there's a bit of work on the center console and the integration of the climate control system. So the other thing to mention is the Digi cockpit. We're a long way down the road with the Digi cockpit now. We've got one major element of the safety monitoring system left to do, but functionally that's in a great position. It works really well.
Can you please add an option to the intercom for the routing of the radio to be P1 or P2 and still allow intercom with the passengers on the back?
We may well have that capability already. I'll need to check with Eric. The stuff that we've exposed in the user interface on the Digi cockpit is only a subsection of what the underlying audio panel can do. So we may have that already. If you ping me that question in writing, I'll check what underlying capabilities we could expose and have a look at that.
Okay. Do you want to just expand a little bit on IFR certification future plans?
Yeah, it remains really important to me that people can get the most out of both HX and HC50. So once we've got the basic aircraft type approved and then certified for the C, we'll be immediately pursuing an IFR variant. So that will mean extending the digicockpit into IFR approval and adding the redundancy that's necessary to do that. So that remains the single highest priority post getting the basic aircraft done, because I think it's imperative for the HC sales, and I think it's a really, really, really important thing that we get private helicopter pilots that fly regularly, so that the guys that are flying 100, 200 hours a year to be IFR approved as a matter of course, because in so many areas of the world, low cloud and limited visibility is a problem for helicopters.
From James, he's saying congratulations, and the question is, any chance of incorporating a heat exchanger in the future, like the one on the French Turbotech engine, in order to drastically reduce the fuel consumption?
So I have answered this question at length before. So in the very, very early days, and I'm talking probably as far as 20 years ago, I was quite obsessed with this idea. Because it does lots of things for you. You put a heat exchanger on, it drops the pressure ratio that you need for your compressor, so all of a sudden you can make a compressor out of aluminium or stainless steel, which is cheaper and easier and lovely in every way. But lots of people have tried this recuperated cycle gas turbine stuff before, and there's lots of work in, I think, the 70s and 80s with aircraft companies trying to do it. There was lots of work with ground-based turbine companies. Solar did a load of work on recuperated engines. And if you go back to the 50s, 60s, and even the early 70s, when automotive companies were trying to put gas turbines in cars, ironically, because they thought they could make them cheaper than complex petrol engines, they all were recuperated to improve the off-design performance and to improve the cycle efficiency. But nobody has ever got the heat exchangers to a point where they can be reliable enough in most duty cycles, but certainly in an aircraft duty cycle where you hot, cold, hot, cold, hot, cold, start, stop, hot, cold, they just become really unreliable. And the only way to make the heat exchanger small and lightweight really drives you down a path that makes it difficult to make them reliable for the long term. So I took a long, hard look at the economics of operating a helicopter, both for commercial applications and privately. And if you are honestly, as an operator, paying the full cost of your own aircraft, fuel doesn't come into it. Unless you're an outrageously high utilization user, fuel doesn't come into it. It's the cost of the aircraft, it's the cost of insurance, it's the cost of maintenance, it's the cost of finance. It's all of those things that drive the cost, not fuel. So fuel is that's not the parameter you want to try and minimize for a helicopter. It's a nice to have, but it's not going to drive cost and it's not going to drive performance. So we elected to stick with a basic Brayton cycle, a non-recuperated engine, push the pressure ratios up, and my approach to improve the fuel efficiency will be to go to a two-stage compressor, higher pressure ratios, and then cooled blades that allow me to just drive the thing hotter and harder, and we can get most of the way to what a practical recuperated cycle can do in terms of efficiency, but you won't have any of the potential pitfalls with long-term reliability. So I don't think you will ever see us do a recuperated engine with a heat exchanger on, because I don't believe they can ever be reliable in this application.
Okay. Where are you planning to do your flight testing?
That's a very good question. We still have options open to us at 2 local airports in the area. So the ground running will be done here, and once we know that all the important stuff works right, we'll decamp and move to one of the local airports. Though we have some lovely offers to do it in Portugal and various other places as well. So we're not short of opportunities for that.
A lot of sun in Portugal. Assuming buying the HX50 with skids, what comes with it for transport? So wheel tugs, are you designing a tug?
So as it stands at the moment, we've got two types of undercarriage, wheels and skids. The wheels can be fitted with the HeliMove system, which we've talked a little bit about in the office today. The skid undercarriage has the option for over-center wheels, so that you can maneuver that on the ground, and we will be providing the little eyeball on the underside of the fuselage, so you can pick it up with an existing HeliMover. We will look at the option of doing HeliMove over-center wheels, but that we've done nothing on that at the moment. So if you want your aircraft to be convenient to handle and faster than the skidded version, your best bet is to have wheels.
Yeah. Good. And Alex is saying, when you look 100 years into the future, how do you imagine helicopters that you've created and the company that you founded? What legacy would you like to leave for future generations, not only as an engineer and entrepreneur, but also as the founder who dared to dream a dream into reality?
I think for me, the thing that's most important to me is that we create products that allow the general aviation industry and business aviation to thrive. So I'd like to continue to develop products that people want to buy, products that allow aviation businesses to make more money and to be able to operate with a level of financial certainty that just hasn't existed since the 60s and 70s. And so our product range will continue to grow to make people that want to own aircraft for fun or operate aircraft for a living make their lives better and more profitable. So that's the first thing that's important to me from a business point of view, from that angle. In terms of what I would like to do technically, I'd like to continue to drive our engines to be more efficient and more environmentally responsible. So the use of synthetic and biofuels is a standard feature of GT50 and will always be. And then as the electrical age continues to develop, there will at some point in the future be a means of storing electricity that is sufficiently energy dense to allow us to make electric helicopters. And the moment that happens, we will pivot overnight. Because the electric motor side of it, the power electronics, you've already seen us do it on a smaller scale with the starter generator. So we'll pivot overnight because it makes helicopters simpler, cleaner, cheaper, easier to maintain. It makes everything about them better, but it's not going to work for at least 20 years. You know, that's the reality of what it's going to take to make batteries good enough to make real aircraft with real performance that people can use or make money out of viability. The other things that are important to me is I'd like to continue to push the speed envelope with helicopters a little bit. And so a suite of technologies that keep vibration under control as you edge up another 10 or 20 or 30 knots. And I'd like to continue to pursue I'd like to start to pursue technologies that make helicopters a little bit quieter as well. It's relatively easy to do for the engine, and the ducted tail rotor helps a lot, but there are some things that we can do with the main rotor that'll make a big difference to that. And so I'd like to get the manufacturing, I'd like to get the industrialization of general aviation sorted first, so just continue the work that we're doing at the moment, get HX50 and HX50 into production, prove out that and the support for all of it. But then I'd like to make the helicopters themselves better, more cost effective. I'd like to keep driving the prices down, not up. And I'd like to just make general aviation thrive again. I want to make it cool again, and I want to make it thrive again.
Very clear. What was the RPM of the GT50 that we heard in the video?
It depends which bit Niall actually clipped the video to. So we ran it up to 27,000 RPM, which is 55% of nominal. And for a brief period, I started dropping it down just to see how low it would go and still self-sustain. But I didn't take it as far as it would go. So I think we went down stably to 24,000, and I eked it up to about 33,000 before I got the got a hold of myself and said, no, don't do anything silly on the first run. Let's get the data, have a look at what it did, and then we'll go back properly and push it. So 27,000, we had a little blip up to 33,000 for a moment, and it was still happy as Larry at that as well. So nominal red line for the engine is 48,520. So at max power, at 500 horsepower, at 10,000 feet on an EASA plus 15 day, it's doing about 48,520 RPM on the gas gen. So we haven't got much further to go.
Mm-hmm. And since the start, have you run the engine again? I mean, what has
we did a
data and fuel consumption. Probably you don't have that.
We have a little bit of that. So first question first: have we run the engine again? Yes. We ended up just pushing through on the first run day, and so we did actually run it for the first time at 51 minutes past 3 in the morning with just the guys that had built it here, and it's a very big deal to everybody in the company. So about a week and a half ago, we did a second run, largely for the staff, and that's the one that I invited Peter and Mike to come and see to give them the opportunity to contribute to the video. So we've run it again. We got exactly the same results. It behaved in exactly the same way. We've actually had the boroscope in the engine in between the two runs as well, and had a good look around, and it's very happy inside. There's no rubs, everything's clean, everything's working exactly the way we expected it to. So we've done 2 runs to date. We've got a bit of a funny couple of week period now where a number of key people are away on holiday, quite rightly, and so we'll pick the testing up again later in the month, get it turned around in the test cell, get the containment structure on, and then start systematically working it through the higher load cases.
Okay. Ian's asking, how are you dealing with risk with multiple R&D and series production developments? So plane, heli, and engine. I've seen firsthand in-house fighting for resources, making project costs more and taking longer.
Well, that risk doesn't exist, does it? Because there's nothing being done on the aeroplane. The HX50 team will move on to AX50 when HX50 is done, not before. So no squabbles, no resource problems. In terms of what was the end part of that question?
I was just talking about
cost.
the cost and the resources.
Okay, so the cost
getting driven up.
So yeah,
multiple projects.
I think you have to understand that we've just built the first gas turbine engine since the 1960s in the UK, and we've done it on a shoestring budget with a tiny team. The amount, you'll remember from some of my very early presentations, that the amount that it costs to do these things isn't related directly to the things you're doing. It's related to the type of company you are. So if you were to ask the Defence Department to try and develop one of these engines, their budget would have started with 9 figures, and it would have taken them a decade. If you do it with a very small team of focused, smart people, and you manage it properly, you can do it on a tiny budget, and that's what we've demonstrated here. And so we will have just enough people, but the right people. And one of the things that we're going to do off the back of this engine run is launch a very big recruitment campaign. Not big in terms of we're after hundreds of people, but big in that now that we've demonstrated the level of capability and credibility and strength that we have as an organisation, it gives me the ability to draw some key people that we've been looking for a while out of different organisations that can contribute very profoundly to what we're doing. And so we're going to enhance the team, and that allows us to keep doing the things that we've been doing the way we're doing them, but faster and better. So I'm pretty comfortable with where we are on that. I don't expect any of our future projects to cost any more than what this one has, to be quite honest. And of course, as we get into production, then the business just rains money. You know, this cutting out all the middlemen and leaving yourself a decent margin gives us plenty of money to be able to reinvest into facilities, reinvest into R&D of new products. So our strategy basically will launch a new product every year. So launch the development of a new product every year and just sequence them in 1 year intervals. So as each product moves through the development phase, they need different things in the resources, and so they just increment through different parts of the team. And after that, it takes as long as it takes. We'll just work through it, we'll fund it ourselves, and we'll just keep going for as long as people want to buy the products, as long as people want us to make different products.
Noel Sharp is asking, is there any requirement to run this engine regularly, like on the ECU 120? In which case I will have to teach my neighbor to start it. Any idea of that interval?
No is the simple answer to that at the moment. I can't answer the question on that interval. Most of those sorts of requirements tend to come out of keeping a film of oil over some of the steel components that are not as inherently corrosion resistant as some of the superalloys and the aluminium parts. So we may end up with some requirements from that to keep your gearbox healthy and some of the bearings healthy. But until we've completed some of the aggressive corrosion testing and environmental testing and got some more hours on the engine, I can't really say anything intelligent about that. But all machines need to be used. They don't like being sat there doing nothing.
Mm-hmm. Very good. Jim's asking, he's from Norway, says, I have serial number 194. When can I expect the schedule and payment plan for my delivery? So how far in advance do I need to spec any of the additional equipment? When's the second payment?
You don't
go over that again, please?
Yeah, you don't need to specify any additional equipment until you get to your 3-month payment. That's when you can define those sorts of things. So I think we will have clear visibility of the production schedule once we get the other side of first flight. So again, on the assumption that first flight goes as well as the engine testing has just gone, at that point we'll put a indicative production schedule out there, and the dates associated with that, with each serial number will have their 12-month and their 3-month payments called based on that schedule. I can't tell you that that's going to be 100% accurate 12 months out from starting, but that's the way we're going to do it. That's the best information I'll have at the time. And that will also be identical to our production planning and how we're buying off the materials and making sure that everything's here to support that level of production as well. So it's a very carefully balanced machine between the payments coming in from the customers and what we're doing with our suppliers and capacity here. So it is important we all stay coordinated.
Okay. With the information you have right now, being the engine has been run, what is how confident are you about the specific fuel consumption and also testing the engine altitude, TPO?
Yeah. So I didn't answer that. I should have answered that in the last question. So the one thing, it was one thing for the engine to run. We'd got very limited instrumentation connected for the first run, just the stuff that we needed to get it safely running. But obviously we'd got fuel flow, and the fuel flow was right on the money at ground idle. And that's usually the bit that's the most difficult to predict, because the maps that we've got for the compressor and the turbine and everything else are least reliable down at the bottom end. So the fuel consumption is exactly where we expected it to be for ground idle. Now I can't say anything intelligent about where it will be for the higher power states until we get it there. But as soon as I do, we'll report it. But the thing that you need to understand is that we've set all of the parameters up in GT50 very conservatively. So if it doesn't hit the power, we either turn the temperature up, or we either just open the compressor and the nozzle guide vane up a little bit and let it pass a bit more flow. Then you've got the power. And if we don't get the fuel efficiency quite where we want it, again, we've got the ability to just tweak where we sit on the compressor curve, tweak the temperatures a little bit, play with tip clearances between the components, just wind those in a little bit until we get to where we want. I have zero doubt about hitting the performance numbers with this engine. It's not going to hit them the first time we run it to the range. We're going to have to tune it a little bit like we've tuned everything else, but it'll hit the numbers. Zero doubt.
Very good.
Fantastic.
High confidence. Next question, simple one. 4-blade twin in future? ?
It would definitely not be 4 blades. I don't like 4 blades. But yeah.
Okay, that's it. Nothing else. That's it. It's not 4. That's it.
Okay.
Can't say anymore. That's not 4.
I've got some very strong views on what a multi-engine helicopter needs to be, and I had a go in a helicopter that has been my pin-up since the last 15 years or so, and it's a very well-used machine here in the UK, and I was horrified to find out that if you fill the fuel tanks up, despite it having sort of 8 seats, it's got a payload of about 207 kilos, and it was the most disappointing thing that I've ever come across. So our twin won't do that. It'll need to be a lot bigger to make sure that we can carry a useful payload. But if you make your own engines and you make your own structures and you make your own rotors and everything else, you've got the ability to make it whatever it needs to be. I'm not penned in by the cost of bigger engines and things like that. So we'll make a great one, but just let me finish this first.
So how many more hours are to expect to put on the test engine before the first flight?
If testing goes well, somewhere between 500 and 1,000, I would imagine. If it doesn't go well, more. So and then once we've got the loads, the measured conditions, the vibration spectra, and everything else that we want, the engines that we use to qualify the TBO and the in-service intervals and all of that stuff, that'll run between 5,000 and 10,000 hours. We'll run those engines into the ground, but that will take a couple of years to get to that sort of level with it running 24 hours a day in the test cell. So that will straddle production, and we'll start with lower TBOs like everybody else does, and then wind those up as we clear the engine.
Okay. I gotta say something, Jason.
Yeah.
Gotta say something, Misha. Gotta say something here. You know what it is? It's knowing you now for so many years, and the fact that you put numbers out there. You just mentioned that with the engine. They're always conservative and very large margin of safety. My personal bet is that you're going to be right on in that number you said, which implies that things are going to go well. I know that because I know you enough that you have those margins of safety. So 500,000 hours is my bet. We'll see. It's recorded now. Yeah, let's see.
I said it in the video, and it wasn't an exaggeration. None of us could have hoped for that first test to go the way it did. It's outrageous that it's gone as well as it has, and we're just at the beginning. There will be lots of problems as we continue the testing, but we'll fix them like we do all the others. But it's outrageous for it to have gone as well as it has to date. So touch wood, it carries on like that, but I don't think we're going to be far away with any of these things. I think they're going to work pretty well.
Okay. I think this next question, we've hit it from multiple angles, so I'm not sure that there's much more to add, but feel free to add something if you'd like. So it says, any plans for a higher horsepower version of the engine? So like getting into GT80, GT100, etc. Anything you want to add there, or is that
absolutely absolutely? GT50 is at the start of its development journey. The GT50 engine platform can be a turbo shaft, a turbo prop, a turbo fan, a turbo jet, a turbo generator. We can do anything we want with that engine. So at the moment, we've got to stay focused, and we've got to finish the core offering for the helicopter, prove out the platform, prove out the support, prove out everything we need to do to get this template working, and then we'll run multiple exploitation streams on different product lines to make as bigger impact on this market as we possibly can.
Any idea of the impact of having the floats on the weight? We know that the floats are inside the airframe, so no drag issue on the weight. And will it affect the cruise speed with that increased weight?
So no, cruise speed isn't that sensitive to gross weight. It's very, very insensitive to gross weight. So no, it won't affect the cruise speed. Yes, everything that's on that options list will make the weight go up. So you can't have it all. Everybody would like to pimp the helicopter and have everything on the list, but it's a trade-off between the additional weight that you're adding and whether you really need that stuff. So And I think if you're going to have floats, a nice trade-off might be to have the skids. I can't believe I'm saying that, but a nice trade-off might be to have the skids.
Jason, don't say things like that.
Because the skids are lighter. The skids are quite significantly lighter.
Yeah.
So if you did it that way, it could be weight neutral.
Yeah. Would one exception be? This is actually the next question. Funny enough, would one exception be the blade fold? Is that going to have a major effect on weight? It's not,
No.
right?
No. No, that's pretty weight neutral. It's a different type of pin in the hub. The only time it would hurt you a little bit is you'd have to, if you were using the mobile version of the blade fold system, you'd obviously have to carry all the props to be able to support the blades when they're folded back and tied back to the structure. You can't just leave them dangling behind. So there's a little weight penalty there, but nothing major. It's not going to spoil your day.
Yeah. Okay. All right. Ruben, you want to go with the next one?
Yeah. Where are you going to be doing the hot and cold weather testing in Airframe?
I haven't decided yet, to be quite honest. I'm totally absorbed by making the engine and all the key systems work at the minute. So all I can say about that is somewhere hot and somewhere cold. But I don't know yet.
Places in the world for that.
Yeah, that's the least of my worries.
Yeah. Okay. That sounds good. We're going to be wrapping up in a little bit here. We've got a few more questions to go over, but it's been an incredible session. Again, this has been a record-breaking one. We've hit about 5,000 people that have tuned in and watched this, and I know there's going to be so many more over the coming days and weeks. If you guys want to share this with somebody as well, this is obviously recorded on YouTube, so share it with somebody that you think would find this program interesting. And obviously the incredible announcement of the engine running. So definitely do that. Share it with your flight clubs, your flight school, your instructor, whoever you'd like to. And it's great to be able to have as many people know about this as possible. Next question is from Mike. So when do you anticipate being able to reveal the new expected horsepower of the aircraft, follow all the upgrades and lightening of the engine?
That's a strategic decision. When could I announce them? Right now. We haven't decided when we'll do it strategically yet. Definitely this side of Christmas. So, but I don't know when yet. So all of those things are defined. It's just choosing the moment to do it. And I think it's best done when we can illustrate it to you. So it just takes a little bit of time to get the visuals done and present it properly.
Okay. Excellent.
Okay. Are you guys planning to dismantle the engine before running the other tests in order to inspect for early issues?
As I said earlier, from the ignition test, we've already had the boroscope in there and given a very thorough review of it. We will dismantle it as soon as we've done the envelope expansion test. So we'll have a look as soon as we've run it all the way up to the highest speed point, just to make sure we haven't had any rubs. Oh, that reminds me, I need to tell you about that as well. Any rubs or any early issues in there. When you watch this back, and I'm sure many of you will, when you look at that shot of the back of the engine, you can see some little sparks coming out the back of the engine. That's not a problem. One of the things that we did that was really clever is one of the things that's critical to setting up the tip clearances is knowing exactly what the running clearances are. But if you can imagine trying to measure something that's spinning at 50,000 RPM, it's very difficult. Now, there's lots of really expensive bits of equipment and dynamic sensors that you can buy to do that, but they're hundreds of thousands of pounds. So what we did is we used an abradable coating and created a couple of little nibs on the abradable coating that as the engine speeds up, it just rubs off bits of this abradable coating, and of course as that goes through the rest of the engine it gets quite hot. So when you look at those little sparks, they're not sparks, they're bits of innocuous abradable coming through the engine, so that when we do strip it, we know exactly where the blades have been and how close they got to the shrouds, and that will be one of the key parameters we use to really tune up the engine and get the performance to where we want it to be.
Okay. Very good. Next question, I'm going to ask it in just a second, but I did want to review what the current offer and the current conditions are. We're actually We've done this at other GMDE events before, etc. Normally the price increases every 4 serial numbers. However, for this big announcement that we have here with the engine running, we're actually freezing the price now for the same time frame as we are with the Elevate and the Raising the Standard program. So until August 20th at 3:51 a.m., we're going to be locking the price for the HX50 and the HC50. So it's the huge discounted price, almost £100,000 discount on the HX50 and almost £140,000 discount on the HC50. So those prices are actually going to be locked for anybody that's looking to order the aircraft now. If you've been on the fence, if you've been waiting for the engine to run, if you've been to one of our presentations before and you said, yeah, I love the program, I love what Hill's doing, but I just want to see that validation of the engine running, if that's you and you're ready to make that jump now, I'd suggest making that sooner than later, because as of August 20th, that price is going to continue to increase again. And so you're definitely never going to get a better price than you would right now. So that's for the main offer. Again, to review the Elevate offer. So what that basically is if you're a new client, if you're ordering the helicopter now, normally the deposit for the HX50 is £30,000. And if you want to take advantage of the Elevate offer, you could actually increase that deposit to £50,000, so an extra $20,000. But then you actually get £25,000 of options for free. And so you can choose a couple different options there that are you can select from. So it'd be either the 4-axis autopilot or the floats. And so you can choose one of those, and you end up getting those options for free just by expediting or moving forward that payment. And then finally, the Raising the Standard is for any of our clients. So if you're a client right now watching this and you want to participate in the acceleration of this program, building the bigger facility, getting your aircraft even sooner, like Jason said, with expanding the capacity that we have, if you want to participate in that, you can do so with the Raising the Standard program. So that is basically you're moving up your next payment. So the second payment that you'd be doing, you move up a portion of that. So $50,000 of that payment you would pay now. And then that actually gives you £50,000 in free options as well. So it's the 4-axis autopilot, and then you get to choose if you want to also have the heli move and the blade fold, or if you want the emergency floats as well. So it's all going to be on the links. You guys can check that out if you want to. But those are ways that if you're a new client or an existing client, you can participate in the acceleration and the expansion of Hill Helicopters, getting the aircraft's to market sooner as well. So definitely, take a look at those if you want to be supporting that. Next one is about, have you done anything so far, kind of preliminary work in getting things set up like service centers, parts distribution, etc. for the US and different parts of the world? So what stage are we at in that? When are we going to be launching that officially? We've been taking informal applications for a long time now. We have literally hundreds and hundreds of applications worldwide. So you want to go over that a little bit, Jason?
Yeah, I think that, again, the trigger point for that, and it's really just about us having the internal headspace to deal with it here at the factory, will be just after first flight. Once first flight triggers a lot of things. It triggers the immediate launch of the Global Production Center, and it also triggers all of the customer support activities to get the insurance in place, to get the service and support centers in place, and to get all the flight training provisions in place for people as well. So expect that to happen very shortly after first flight. So it'll probably be attached to the first flight global meetup and the online event that we do for that.
Yeah.
Questions, and then we're going to be wrapping up and closing this very, very special session. It's going on now for about 2 hours and 20 minutes. We're going to go with the next one. Let's see, we can pick here something. Okay, that's interesting. The helicopter engine is behind you. Okay, the helicopter engine is behind you. And I'm trying to fit the engine in a machine, but in my mind, it does not fit. Where's the engine going to sit? Okay, so is there any change in the location of that engine? Because there's people now trying to see where this engine is going to fit with the information you have given about that. Some little changes we're doing for the better.
The fuselage is enormous compared to the engine. It's just a perspective thing. The engine's really close to me and the helicopter's a long way behind to get everything in shot. So the engine is very small in that engine bay. And remember, a lot of the upper fuselage is just cowlings, and we've got a very flat, deep engine deck on the back, and about a quarter of the height of the tail boom is actually a flat top deck for the drive shafts for the tail drive mechanism. So again, leave that until the next AMA, and I'll show you all of that graphically so that you can see the layout. It fits really easily. It's very elegant. And when you take the cowls off so that you can get into inspect, it's really easy to inspect everything as well. So fear not.
Very good. Jason, I'm going to ask the last question for you today. I'm just going to expand the question a little bit because I think it covers everything. But before I ask it and before you answer, I just want to say a huge thank you to everybody that was present today. Being part of witnessing this major milestone, not just in Hill Helicopters history, but I think in general aviation history as a whole, because I know that 20 years, 30 years, 40 years from now, people are going to be looking back at this moment and this milestone right here and say that was the pivotal point where I think aviation changed as a whole. And I think we're going to be looking back in 40 years going, wow, it's incredible to see the impact across the board of what Hill Helicopters has done. So I want to thank you for that. I want to thank you and the whole team for it, because I know that, you mentioned Niall earlier, what an incredible effort he's done on this whole project from a media side to be able to present this to everybody. And you mentioned it during the video as well, but the tireless hours that yourself, Mark, the entire team, every single one of the engineers in the design room, on the shop floor, that they've put into this project, that their team have sacrificed as well, that their family have sacrificed as well to be able to make this happen, and will continue to do so. This project is not done yet. We have a little while to go before first flight and production starts, and it's just around the corner. But the continued commitment is incredible, and I just want to thank the whole team for that right now at this point. So thanks everybody for tuning in.
And let me just add to that and just reiterate what I said in the video. There's a huge debt of thanks goes out to Mark Webb, our production director, because he and his team built that engine, and they've done it in a record time. And I set them a spectacularly difficult task of having to actually manufacture everything rather than just assemble some bits we'd bought in, and they've aced it. They've knocked it out of the park. So a huge debt of gratitude to Mark, a huge debt of gratitude to the design team, to the production team, to all of our logistics, accounts, support team, everybody here in the company that makes all of this stuff happen, because it wouldn't happen without them. And then to all of the families of the Hill team, a huge debt of gratitude to them, because they've had to put up with a lot while we've been working everybody so hard, and they've done it flawlessly. So we're very, very lucky to benefit from the amount of support from everybody involved in the program that we do. And of course, the biggest thanks has to go to those 1,000 or so brave aviation pioneers that were prepared to trust us when the whole world was saying I was a lunatic. And I still might be, but at least we've got a new turbine engine now, and soon we'll have the helicopter in the air too. So thank you,
beautiful.
Everybody.
That's awesome. Let's get those 1,000 owners to jump into the Raising the Standard program, and we'll all get our aircrafts a little bit sooner as well, which will be nice. So the last question, I'll expand it a little bit. So is the HX50 a good option for training future pilots? And I'm just going to expand that to say, where does the HX50 and the HC50 really shine? What's its main purpose? Why is it valuable for the people that are going to be using it?
So the main purpose of the HX50 is to be the best helicopter at any price point that you could possibly buy if you're a private owner operator. And I think with an increase in uptake of people, new people wanting to come into general aviation, new people wanting to own helicopters for themselves, because there's now an aspirational product to go out and aspire to own and aspire to learn to fly, then I think the HX and the HC50 are the perfect helicopters to start with, because if you're new to it, why wouldn't you build all the experience on the machine that you're going to subsequently fly? And I think from the point of view of getting new people into aviation and starting their aviation journey, why wouldn't you want a really benign rotor system, large power margins, the best crashworthiness in class, the lowest workload for the digital cockpit, all of the creature comforts of proper iPad integration and an autopilot system? Why wouldn't you want to learn to fly with those sorts of things when the price to operate it is less than anything else that you can buy at any level in the market? So I think for private owners and for flight training of private owners, it's the perfect platform. And then for HC, I think that will really dominate the light commercial market, because anything that involves moving people, it's totally peerless. It has no natural competitors at all, because nobody has a cabin like us, nobody has the performance like us, nobody looks like us, nobody's going to be as smooth as us, and nobody can touch us on price. So if you want to move people on a charter op, if you want to do heli tours, if you wanted to do anything with that side of the light commercial operations, it's totally without question the best helicopter available anywhere for that. And I've always said that the helicopter that private owners buy tends to have nothing to do with the mission and more to do with how deep their pockets are. And because generally the more you spend on helicopters, the more they look like proper helicopters. Well, that's not the case anymore. And so I think both of those products have a very strong future. We will look to toughen up HC50. One of the opening variants, the opening trim levels that we provide that with, will be a much more rugged interior for people that want to do agricultural work or long lining and those sorts of applications where you don't want all the leather and the bells and whistles, and we can lose some of that weight with lighter trim and lighter seats and give you a bit more performance. So I think it will be the de facto light helicopter for many years to come.
Amazing. I was thinking about it recently, Jason. I've just mentioned this at the end here. I may actually go for the utility version in my helicopter. I might go for cloth seats and a little more of the utility version, just to save a little bit of that weight, because some of those options are very tantalizing. So it might be nice to have one of the three as more of a utility version, and yeah, a little more operational that way. So we'll see how that goes. But thank you again for your time.
Not if you're planning to go on the world tour in it. You're having a posh one.
There you go.
He's going to have to rethink one, I think.
People need to be able to see the utilitarian side as well. So we've got two posh ones and
I'm happy.
One operational.
Yeah.
I'm happy Bichet is the volunteer for that. I'm happy. Yeah, that's good. That's good.
You're gonna have to make some incredibly beautiful cloth seats, though. I promise you that. Jace, thanks again for your time. Thanks for doing this. I know that you work tirelessly to prepare these and take your time for it. I know you haven't slept in days as well, and so thank you for that. And I just appreciate everything that you do and continue to do. So thanks for your time.
Thanks, guys, and thanks everybody for tuning in and watching it. We really appreciate it.